All right, in this lesson we will be learning about different systems of inequalities. So they have inequality symbols in them. Um, this you will just want to write down here. We will shade below the line if it's that symbol, less than or equal to. We will shade above the line if it's greater than or equal to. Um, we will do dotted lines, and we've done this before, but we will have dotted lines if it's less than or greater than. We will have solid lines if it's less than or equal to, or greater than or equal to. And then, of course, we need to remember to switch the direction of the inequality whenever we multiply or divide by a negative number, and only when we multiply or divide. Okay? So here's two equations. First of all, you want to get them into y equals mx plus b form. These two both happen to be in y equals mx plus b form. So here's what you want to do. Okay, I will first of all look at the blue equation. It's in y equals mx plus b. I can see it crosses the y-axis at 1. Right here. It has a slope of negative, and this is really 1 over 1 right here. Negative slopes, remember, go this direction. So that's the direction that line is going to go. And that means my top number tells me to go down 1. My bottom number tells me to go right 1. So down 1, right 1 is how I would do this. Or, of course, I could go up 1 and left 1. So that would work as well. Since the inequality symbol is not underlined, I will connect those dots with a dotted line. And since it is a less than symbol, I will shade below the line. Okay, and again, you have two choices, up here or down here. And it's B in this case, that's below the line. Okay. Moving on to the red line, I can see it has a y-intercept of 3. And it has a slope of positive 2, which is 2 over 1. Again, the top number tells you to go up 2. The bottom number tells you to go right 1. So up 2, right 1. Or I could go down 2 and left 1, which is how this will go. That inequality symbol is underlined right here. So because it is underlined, I will connect them with a solid line. And it is less than, so I will shade below the red line. So here's your choices for below the red line. Okay, A or B, and it is B that's below the red line. Okay. And now, really, what I want you guys to do is your true solution to this, actually, would be to erase anything except for the spots where you see both colors. But most of you aren't, I don't want you to mess with the eraser. I don't want to hear all the eraser marks. I don't want to do all that. So what I want you to do instead is I want you to darken in your solution set for me. And again, your solution set are only the spots where you see both colors. So I can't really make this very dark on here, so what I am going to use is I am going to use a highlighter instead. And I will darken in, or I will highlight the solution. So for me, the solution set is going to be in this region in here. It's the spot where I see both colors. You can really darken that in. I want it to be very evident on your homework or your quiz or your test, but that is your solution set, the spot where you see both colors. Okay? Here I've got two equations that are not in y equals mx plus b form, so I need to get them there first. So in that first equation, the blue one, I will subtract 2x. And since I'm subtracting, I don't need to switch the direction of the inequality. I'll have negative y is greater than or equal to negative 2x plus 2. Can't have negative y there, so I will divide by negative 1 all the way across. Now I did divide by a negative, so I do need to switch the direction of the inequality. 2x divided by negative 1 is positive 2x. 2 divided by negative 1 is negative 1. So there's my first equation. I'm going to go ahead and graph it here. It does have a y-intercept of negative 1 and a slope of 2 over 1. So that means I'm going to go right up to right 1 or down to left 1. It is underlined, so I will connect those dots with a solid line. And it is less than, so I will shade below that line. Okay. For the red one, it is not in y equals mx plus b either, so I will subtract x. Then I have negative 2y is greater than or equal to negative x plus 2. Divide by negative 2. And because I divided by a negative, I do need to switch the direction of the inequality. And then I will have negative 1, there's a 1 right there. Negative 1 divided by negative 2 is positive 1/2 x. 2 divided by negative 2 is negative 1. So this also crosses the y-axis at negative 1. It has a slope of positive 1/2. You know what? I messed this up. This should have been negative 2 right here. Okay, hang on. I'm going to fix this. Good thing I caught my mistake. You guys probably caught it, and I did not. Sorry. That's what happens when you don't have a live audience in front of you. Okay, so hang on. Back to the blue line. It has a y-intercept of negative 2 and a slope of 2. Let's fix this really quick. It just was at the wrong y-intercept, okay? I connected that with a solid line, and it was shaded below. So the only thing wrong was that it just crossed the y-axis at the wrong spot. Sorry about that. All right, back to the red line. It crosses the y-axis at negative 1, and it has a slope of positive 1/2. So that means I'm going to go up 1, right 2, or down 1, left 2. And it is underlined, so I will also connect it with, connect the dots with a solid line. It is less than, so I would want to shade below the line, okay? So again, instead of erasing everything, I'm going to have you just darken in the actual solution set, which is the spot where you see, or the area, the region where you see both colors. So in this case, that's this region in here is your solution set. So you go ahead and really darken that in, make it very evident to me that you know that that's where you see both colors, and that's what it would look like. On accelerated math, just so you know, when you do your homework, these things will be erased, but I'm not going to have you take the time to do it just because I don't want to deal with the mess. But technically that's what it should look like, is that. Okay? All right, then we've got ones that are just simply horizontal and vertical lines. It's been a while since you've done this, but here we go. The blue line, remember, is a horizontal line because y is being held constant at 5. So it is a horizontal line at 5. It is not underlined, so it will be dotted. Okay. It is less than, so you will shade below that line. So that one would look like that. The red line is a vertical line because x is being held constant at negative 2. And so it's a solid line because it's underlined at negative 2. And it is, I want all the spots that are greater than or equal to negative 2. So that would be to the right of negative 2. And your solution set again is the spot where you see both colors. So in this graph then, I see both colors in this region in here. And here's where I would want you to really darken and show me for sure that you know that that is where your solution set is. Okay? And then one more. Again, these are not in y equals mx plus b forms, so I will get them there first. I will subtract x here. Then I will have negative y is less than negative x minus 1. Divide by negative 1. Because I divided by a negative, I switch the direction. So I have positive x plus 1. Okay, I'll go ahead and graph that. It does cross the y-axis at 1. It has a slope right here of 1 over 1. Okay, so I will go up 1, right 1, or down 1, left 1 would be the other thing you could do. And it is that inequality symbol is not underlined, so I would connect those with a dotted line. and it is a greater than symbol, so I would shade above that line. Okay, now let's look at the red one. I will subtract x, and I will have negative y is greater than negative x plus 3. Divide by negative 1. Y is less than, I have to switch the direction because I divided by a negative, x minus 3. So this one crosses the y-axis at negative 3. It also has a slope of 1 over 1. So it will look like this. And that inequality symbol is not underlined either, so I would connect it with a dotted line. And then it is less than, so I would shade below the line. Now, remember though that your actual solution to this is where they intersect. And there is no spot on this graph where I see both blue and red at the same time. So your answer to this actually is no intersection, so there's no solution. Okay? There is no spot where I see blue and red at the same time.